Geometric sequence. Now let's look at how to find the sum of the first n terms of a geometric sequence. Alright, before that you must know the formula we need to use to find the sum of the first n terms of a geometric sequence. Consider the geometric sequence A, AR, AR square, AR cube, so on. Let the sum to n terms of a geometric sequence as Sn. Sn equal to A plus AR plus AR square plus AR cube plus so on plus AR to the power of n minus 2 plus AR to the power of n minus 1. Let's define these equations as equations 1. Okay, next you must multiply these equations by the common ratio r. So you will get Rsn equal to AR plus AR square plus AR cube plus so on plus AR to the power of n minus 1 plus AR to the power of n. Let's define these equations as equations 2. Now, we will take equations 1 minus equations 2. So you will get Sn minus Rsn, right here, equal to A minus AR power of n here. So now we can factorize this part with Sn. So we get Sn times 1 minus r. We also can factorize this part with A. So we get A times 1 minus r to the power of n. So now we will see the formula. If the common ratio less than 1, we will use the formula for Sn equal to A times 1 minus r to the power of n over 1 minus r. And if r greater than 1, you will use the formula Sn equal to A times r to the power of n minus 1 over r minus 1. So these two formula we can use to find the sum of the first n terms of geometric sequence based on the value of the common ratio here. Okay. Next, let's look at the relationship between Tn and Sn. So the relationship is Tn equal to Sn minus Sn minus 1. This relationship of Tn and Sn of geometric sequence is similar to the relationship between Tn and Sn of arithmetic sequence. Alright, now let's look at the example here. You are given a sequence 2, 4, 8, 16, and so on. Alright, let's try to find the sum of the first terms of this geometric sequence. So S1 equal to the first term equal to A equal to 2. Okay, next, let's try to find the sum of the first two terms of this sequence, which is T1 plus T2, right? So you have 2 plus 4 equal to 6. If you want to find the sum of the first three terms of this sequence, we can take T1 plus T2 plus T3 equal to 2 plus 4 plus 8 equal to 14. Alright, but if you want to use the formula that we have discussed before, which is the formula to find the sum of the first n terms of a geometric sequence, we must have the value of the common ratio R, which is, you must know by now how to find it. So R equal to 2. You can take the second term divide by the first term, or the third term divide by the second term. So R equal to 2. Since R greater than 1, we use this formula Sn equal to A times R to the power of n minus 1 over R minus 1. So if you want to find S3, so S3 equal to 2 times 2 to the power of 3 minus 1 over 2 minus 1, where A here equal to 2 and R equal to 2. So the answer is 14, similar to here. Alright. If we want to see the relationship between Tn and Sn, we can try to find T3. So T3 equal to S3 minus S2, which is 14 minus 6. You will get 8. So T3 equal to 8.
Example 4. Find the sum of a geometric series 1 plus half plus 1 over 4 plus so on plus 1 over 256. So the question asks you to find the sum of geometric series, so Sn. Based on the series here, you can take out the informations, which is we have the first terms, or T1 equal to 1. Okay, T1 equal to A equal to 1. And the second terms is half. T2 equal to 1 over 2. Next, we have the third terms, T3 equal to 1 over 4. And the last terms here, which is Tn equal to 1 over 256. Based on these informations, you can find common ratio, which is R. R equal to, we can take T2 divided by T1. T2 divided by T1 equal to 1 over 2 divided by 1. So the answer is 1 over 2 for the common ratio here. Okay, to find the sum of geometric series, you must know the value of R. Now, since R less than 1, which is the value is 1 over 2, you must use this formula Sn equal to A times 1 minus R to the power of n over 1 minus R. Based on this formula, we already have the value of A, 1, and R, half, but we don't have the value of n. So before we can find the the sum of geometric series, here we must know the value of n. So to find the value of n, we can use these informations. Alright, Tn equal to 1 over 256. and the formula of Tn equal to AR to the power of n minus 1. Okay, we can substitute these informations Tn in this formula with the value of A 1 and R half. We have 1 over 256 equal to A 1 R 1 over 2 to the power of n minus 1. Okay, here we have n, the unknown, as a power. So you can use log both sides to find the value of n. So we can have log 1 over 256 equal to log 1 over 2 to the power of n minus 1. We can bring the power of n minus 1 to the front. So we can have n minus 1 log half equal to log 1 over 256. Okay, n minus 1 log half equal to log 1 over 256. Okay, we can divide the whole equation by log half. So we have n minus 1 equal to log 1 over 256 over log half. So, based on your calculator, we get n minus 1 equal to 8. So, n equal to 9. Now, we know the value of n is 9. You can substitute in this formula. So, we have S9 equal to A1 in the bracket 1 minus 1 over 2 to the power of 9 over 1 minus 1 over 2. So the answer is 511 over 256. So S9 equal to 511 over 256.
Example 5. The sum of the first three terms of a geometric progression is 7 over 4, and the sum of the next three terms is 7 over 32. Find the common ratio of the progressions. So we know that this question is a geometric progressions questions, and there are two informations given. The first one is the sum of the first three terms of the geometric progressions is 7 over 4. So take out the informations. We have T1 plus T2 plus T3 equal to 7 over 4. Next information is the sum of the next three terms is 7 over 32. Right? So we know is the sum of the next three terms after the first three terms is T4 plus T5 plus T6 equal to 7 over 32. And the question asks you to find the common ratio, which is the value of R. Alright, how to find the common ratio? You are given two informations. Okay, we can use the formula of Tn equal to AR to the power of n minus 1. Alright, for T1, based on this formula, you will get A plus T2, which is you get AR. T3, AR square. So A plus AR square equal to 7 over 4. Okay, we can factorize this part, which is we can factorize A. So we get A in the bracket 1 plus R square equal to 7 over 4. Alright, let's define this as equations 1. Okay, how about this part? We have T4 plus T5 plus T6 equal to 7 over 32. You can take n equal to 4 and put in this equation. You will get AR to the power of 3 plus T5 AR to the power of 4 T6 AR to the power of 5 equal to 7 over 32. So we can factorize AR cube. AR to the power of 3. So in the bracket we can have 1 plus R square, okay, equal to 7 over 32. If you expand, you will get this answer. Alright, now let's define this as equations 2. Alright, now we can take equations 2 divided by equations 1. So equations 2 divided by equations 1, we get AR cube in the bracket 1 plus R square over A in the bracket 1 plus R square equal to 7 over 32 divided by 7 over 4. Okay, for this part, we can cancel it. We can simplify it by cancel A. Alright, and we can cancel 1 plus R square. So we get R cube equal to, okay, this part you will get 1 over 8. Okay, to get R, you must cube root 1 over 8. So R equal to 1 over 2. Therefore, the common ratio of this progression is 1 over 2.
Example 6. In a geometric sequence, the first term is 7. The last term is 448. And the sum of all the terms is 889. Find the common ratio and the number of terms. Alright, in this question, there are 3 informations given. So the first one is the first term is 7. The first term is 7. So we have T1 equal to A equal to 7. Okay, the second information is the last term is 448. So we have the last term is Tn equal to 448. And the third information is the sum of all the terms is 889. So Sn equal to 889. The question asks you to find the common ratio, which is R, and the number of the terms. The number of the terms is n. So what is the value of R and n? So based on these informations, okay, we can find R and n. First, we will use Tn equal to 448 to be substituted into formula Tn equal to AR to the power of n minus 1. And we already have the value of A, which is 7. So first we substitute Tn. 448 equal to A, 7 times R to the power of n minus 1. Okay, we can divide these equations by 7. So you will get R to the power of n minus 1 equal to 64 after you divide these equations by 7. Okay, now we have two unknowns. So at least you must have two equations to find two unknown. So this is the first equation. Let's define as the first equations. Okay, we can use these informations to form the second equations. Okay, let's say we use the formula Sn equal to A in the bracket 1 minus R to the power of n over 1 minus R. Okay, now we can substitute 889 in this formula equal to A equal to 7. So we have 7 in the bracket 1 minus R to the power of n over 1 minus R. So next, we can divide the whole equations by 7. So 889 divided by 7, you get 127. And this part, if you divide by 7, you get 1 minus R power of n over 1 minus R. Next, cross multiply these equations. So for this part, you will get 127 minus 127R equal to 1 minus R to the power of n. Alright, now rearrange the one with R on the left hand side and the one without R on the right hand side. So we have R to the power of n minus 127R equal to negative 126. Okay, next for this part, we can factorize R. So we have R in the bracket. For this part, you will get R to the power of n minus 1 minus 127 equal to negative 126. Let's define these equations as equations 2. So now, if you look at the first equations, we have R to the power of n minus 1. You can substitute this into equations 2. So, you can say that substitute equations 1 into equations 2. So we have R in the bracket. Okay, this part you will substitute with 64. 64 minus 127 equal to negative 126. So 64 minus 127, you will get negative 63. So you have negative 63r equal to negative 126. Okay, we can divide these equations by negative 63. So this part you will get r equal to, this part you will get 2. So you got the common ratio, which is r equal to 2. Now, to find the number of terms. How to find the number of terms is, you can substitute r equal to 2 in these equations. R equal to 2, substitute into equations 1. So you get 2 to the power of n minus 1 equal to 64. Okay, we can change 64 to the base 2 with the power of 6. So we have 2 to the power of n minus 1 equal to 2 to the power of 6. Since we have the same base, we can cancel this base. So we have n minus 1 equal to 6 and equal to 7. So the number of terms, or n, is 7.